Hello, this is lecture number 7 in the first year Roehampton course, Creativity and Computing. Lecture number 6 was actually spent as a visit out in school and we had a really good time there. So lecture number 7 we're back in for a flipped version of this lecture. What we're looking at today is computer-assisted learning, and I'm interpreting that in a relatively narrow sense of the computer asking the learner, the pupil, the child, questions and then providing feedback on how that goes. And there's much more to computer-assisted learning than that, but this has a long history to it, and I think it's an area which is well worth your getting to grips with, because this is still very, very popular in schools, as I'm sure you'll see when you're out on placement. So here we go. We place ourselves very firmly within the territory of behaviorism as a learning theory here, and I think the simplest way of thinking about behaviorism, the simplest way of understanding behaviorism, is a stimulus, response, reward. So I ask you a question, you respond, and if you get it right you get a biscuit or some other sort of reward like house points or a tick or something like that. And this does seem to work. This is a great way of training pigeons, this is a great way of training puppies, this may or may not be a great way of training children to get certain things right and to respond in a certain way to certain sorts of things. And you can think about this as conditioning for behaviour as well as conditioning for much more subtle things, such as arithmetic questions, such as spelling tests. I ask you a question, if you get it you respond, and if you get that right you get some sort of reward. And we keep going through that cycle, and sooner or later that sort of cycle of stimulus, response, reward does appear to work. You know, we're not quite sure of what's going on in the brain there. Skinner saw this very much in terms of a black box of you have certain inputs and that produces certain outputs, much as we would think of a computer. But for a certain narrow class of things, there is evidence that this does seem to provide some sort of positive outcomes. In terms of creating a behaviorist learning environment, in terms of creating behaviorist learning, then the 4 bullet points on the screen there pretty much sum it up. So when we're practicing, what we do is we have questions, so things are provided in the form of question and answer frames, and the student responds to the questions which they're given. As you're structuring this, the questions should get harder and harder, and there should be some sense of progression there, that each question is just that little bit more challenging than the last. And I think the game players amongst us are immediately thinking of the sort of progression that's present in many a computer game. And that there should be a response to every question that's posed, and there should be immediate feedback on that response. It's no good in a behaviorist learning environment waiting for the teacher to mark a stack of books. What you want is some sort of immediate feedback of how are things going at the time. So if you're trying to do this pencil and paper, you're beetling away around the room, marking their work as they go on, and that's actually well worth doing, I would suggest, if you're doing sort of arithmetic in the classroom. That sort of immediate response to how well is it going is something which I think pupils do appreciate, and which is much more likely to be effective than them seeing their books marked a couple of days later, I would suggest. And of course on a computer you can do genuinely immediate feedback on this sort of thing, and in fact Skinner came up with clever ways of doing that before computers were around, as I'll show you in a little video clip in a little while's time. So as I say, the difficulty of the questions, there should be that sort of learning journey that generally the children are going to be getting those right, or the test subject or the pupil is going to be getting those right because they've learnt from the previous ones, and that it's not too difficult a set of questions, and you do want that set of progression there. And as well as the reinforcement within the learning itself, you know, the tick, the yes, that's the correct answer, you also would typically accompany this with extrinsic rewards, such as house points, such as certificates, such as prizes or commendation on assemblies or whatever. Okay, so I think this is probably familiar to you from the sort of thing which you see going on in many schools still, and might be familiar to you from your days in the primary school classroom. And it's worth thinking about how this sits with some of the other learning theory that you'll have been covering in teaching and learning recently, particularly in relation to Piaget and Vygotsky and Bruner. Skinner is very much there's quite a difference, I think, between Skinner's behaviourist notion and the more sort of constructivist notions of learning that you'll have looked at elsewhere on the course. Let me show you some examples of this. So there's so many examples online of this sort of thing, and it's easy at Roehampton to think in terms of constructionism good, Constructivism, good. Behaviourism, bad. And I don't think that's actually a particularly meaningful way of thinking about this. So, just have a look at some of the stuff which is out there and which children might well. I'll come back to this one in a moment. Let me show you this one from BBC Bite Size. Drag each thing from the menu into the right category. So ice, that's obviously a solid. I'm hoping that I got that right. We're not getting immediate feedback, or are we? Steam is a liquid. No, it isn't. So there's my immediate feedback. If it fits, then it fits. That'll be a liquid. That's a liquid. Milk's a liquid. Let me try with sand. That sort of runs away like a liquid does. Oh, but it's not a liquid. It must be a solid. Gas. Gas. I'm wondering how many of these we'll have to do. And that seems to be it. Oh, we scored this. Not quite extrinsic reward at the top of the screen, an experiment with liquids and gases. So there you have a very simple sort of behaviorist learning environment. Let me show you another set of questions. This is very popular. This is called Manga High. Marcus de Sotoy, TV mathematician, was the consultant behind this. I've got to turn the sound effects on, otherwise you really don't get the benefit from this. So here we go. And these things float down for us. No, I don't really need the advertising here. Let's have another go at that, see whether we can get it to work better this time. Don't you just hate it when that sort of thing happens? Oh, there we go, 1.4, I click on that. 1.8, drag and drop in order of the highest numbers at the top. So there's my positive reinforcement. Stimulus, response, reward. Let's see what happens when I get one wrong. Oh, that's sad, isn't it? 0.8 looks fine. And 2, let's get that one right as well. Oh, no, got that one wrong. So we have now a choice. Click to harvest or wait for the bee to make more flowers. I'm going to wait for the bee. Where's the bee? Don't see any bee yet. Ah, here one comes. There we go. So what happens now? Oh, right. So we get an extra 15 seconds for something. 0.5, 2, 1.5. I think you're getting the hang of this now. I'm going to pause that and thankfully turn the sound off. So really nice game-like environment, but very much still within that stimulus, response, reward approach to learning. This is rather different. This is an online equivalent of a textbook from the Centre for Innovation in Mathematics, teaching the Maths Enhancement Project at the University of Plymouth. And I was using this with pupils back in school, back in my teaching days. So you have here, essentially we type in the answer to these questions. Let's see how we get on trying to do these in my head. Fingers crossed for this folk. 70, and what's that going to be? 70 plus 90 should be 160. Let's try and get that wrong and see what happens. And we ask the computer to mark that. Oh, and we've made a mistake somewhere in there. Well, we think that that's there. Let's try again. Check that. And we've got those right. So we could have a go at another line. Then we get something a little more interesting. Which of the numbers could be put in place of the missing digits so that the numbers are even? Well, that could be 150, could be 152, could be 153, couldn't it? Nope, try again. Oh, and I've got to start the whole thing again. 152, 154. Stimulus, response, and a reward. Okay, not much of a reward, I think we'll acknowledge. Write a plan, do the calculation, write the answer as a sentence, and it means a mathematical sentence. Henry had 70p. He paid a bill with 5 10p coins. How much money did he have left? Well, we'll start with the 70, and then we'll take away 5 times 10, and that's going to be 20 with a bit of luck. Okay. Oh, and the answer here was how much money did he have left? He had 20p left. I can't actually get the computer to mark that because there are obviously too many responses. But you get the idea here. So again, stimulus. Oh, and we get a number puzzle as well. I'm not going to spend time filling in all of that. So that's quite varied. Now, without looking at the heading here, because I think I've got the frame set up so that you can't see the title, it would be worth your pausing a moment and saying, what age group is that aimed at? What year group is that pitched at? Well, in fact, it's year 3. And I think many of us would be, I don't know, you might be surprised about how sophisticated some of the mathematics which MEPA's got to, using this sort of interactive, varied approach to maths on here. So that's a lot more sort of staid and respectable than the sort of fun that you're getting here, but still an online immediate feedback, stimulus, response, reward, behaviorist type of learning environment. Okay, that's probably enough theory for a little while. Now how about a little bit of history? You know we do these things in a number of these lectures here. Well, there's a long history to using technology, not necessarily computers in the sense which we would understand it, to teach in this sort of way. So back in 1912, Thorndike coming up with this notion of essentially a collection of web pages, a miracle of mechanical ingenuity, a book that was arranged so that only those who could do what was asked for on the page could turn on to the next page, and thus a lot which now requires personal instruction could be managed by print. So we have there a sort of set of graded questions that you're not allowed to move on to question 2 until you've completed question 1. You're not allowed to move on to question 3 until you've completed question 2, and so on. And sort of fairly visionary stuff about writing back in 1912. Pressey, back in the 1920s, actually built something a little like that, and there's this kind of illustration of it there on the page. So the teaching machine that he developed resembled a typewriter carriage with a window that revealed one question with 4 answers. There were 4 keys that you could press. You pressed the answer that corresponded to the correct answer. We're talking multiple choice here, aren't we? When the user pressed a key, the machine recorded the answer on a counter on the back of the machine and revealed the next question. But it was only after the user was finished that the person scoring the test slipped the test sheet back into the device and noted the score on the counter. So it would still, it would be marked semi-manually there, I guess. I'm going on too many slides here. This is B.F. Skinner himself and the notion of the teaching machine. I'd like you to have a look at the video here. This is brilliant footage. I think I'll play all of this.
These young people are studying in a new way. Class in spelling, it might as well be arithmetic or algebra or grammar, or in fact anything involving the use of words or symbols. Each student is using a teaching machine, a device which creates vastly improved conditions for effective study. What are teaching machines? How are they used? What can they teach? Who prepares the material they teach? And how does this material differ from textbooks, lectures, and educational television? What impact will machine teaching have on school organization? Some of these questions can be answered in at least a preliminary way.
Does that really look any different from a class using Mathletics or a class using Education City, a class set in front of computer screens answering questions on screen? It's the lack of social interaction in the room that really bothers me about this. Each child just working through their own set of questions on the teaching machine. Let's hear Skinner say a little more about it there.
I am B.F. Skinner, professor of psychology at Harvard University. I should like to discuss some of the reasons why studying with the help of a teaching machine is often dramatically effective. With the machine you have just seen in use, the student sees a bit of text or other printed material in a window. This may be a sentence or two or an equation in arithmetic. Some small part is missing, and the student must supply it by writing on an exposed strip of paper. His response may be the answer to a question or the solution of a problem, but generally it is simply a symbol or word which completes the material he has just read. As soon as the student has written his response, he operates the machine and learns immediately whether he is right or wrong. This is a great improvement over the system in which papers are corrected by a teacher where the student must wait perhaps till another day to learn whether or not what he has written is right. Such immediate knowledge has two principal effects. It leads most rapidly to the formation of correct behavior. The student quickly learns to be right. But there is also a motivating effect. The student is free of uncertainty or anxiety about his success or failure. His work is pleasurable. He does not have to force himself to study. A classroom in which machines are being used is usually the scene of intense concentration. One function of a teaching machine, then, is to give the student a quick report on the adequacy of his response. This is important not only for efficient learning, it generates a high level of interest and enthusiasm. Another important advantage is that the student is free to move at his own pace. With techniques in which a whole class is forced to move forward together, the bright student wastes time, waiting for others to catch up. And the slow student, who may not be inferior in any other respect, is forced to go too fast. Not quite completing one day's assignment, he is even less likely to complete a second. And he gets farther and farther behind, and often gives up altogether unless remedial steps are taken. A student who is learning by machine moves at the rate which is most effective for him. The fast student covers a course in a short time, but the slower student, by giving more time to the subject, can cover the same ground. Both learn the material thoroughly. A third feature of machine teaching is that each student follows a carefully constructed program, leading from the initial stage where he is wholly unfamiliar with the subject to a final stage in which he is competent. He does this by taking a large number of very small steps, arranged in a coherent order. Each step is so small that he is almost certain to take it correctly. The material is designed to give the student as much help as possible. He is not in any sense being tested. Instead, helpful hints, suggestions, and prompts maximize the chances that he will be right.
Isn't that fab, though? There's so much that's interesting there. I mean, it's worth pointing out this business of he has the child marking their own work. The child writes in the answer, cranks the handle round, and then gets to see on the in the same window what the correct answer was, and then makes a mark to say whether they've got it right or wrong. And so you have that sort of positive reinforcement going on all of the time in Skinner's world, where each child is making these small steps at each point. There is, though, this emphasis on each child progressing at their own rate, which is a long way removed from the sort of social constructivist learning where each child is going to be learning through conversation with the other children in the room and the more knowledgeable other, typically the teacher, of course. So quite a different approach. We have other things here. So, for instance, a little while later on, the stuff becomes computerized, and you have a system which was called Plato. This was only in American high schools and junior high schools. So you have one big computer, a mainframe server sat somewhere at the school board's office, and then all of these terminals out there in school. And of course the things were designed to display Skinner-like questions, which the child would then type in their response to or click on the letter. That's the other interesting thing about Skinner, that he was allowing free-form response rather than just multiple choice. I'm not sure as that would necessarily have always been the case with these Plato terminals. And then the school board compute mainframe would mark that, and that would be displayed back on the screen. And of course then the school board builds up that database, that test, that record set of how all of the children in all of the schools are doing. So you can imagine the way these sorts of things would have been sold to American local authorities equivalent. The really interesting thing about Plato, for my mind, is that this was subverted by the technologists. So, you see on the screen there somebody who's managed to install a Star Trek program on the mainframe. And you have that sort of distributed across all of these schools in this district, in the districts in America. And similarly, they were using Plato as a system for computer-mediated communications. Although it was intended in that sort of behaviorist mode, you had Plato systems being used as discussion forum tools way back in the 70s in school, in education. Come the 1980s, and I've shown you pictures of these things, lovely, lovely computers before BBC Micro, and a lot of the software that was produced for them, often by teachers themselves, was about drill and practice. So it's easy enough to code up a multiplication test game on a BBC Micro, and there was an awful lot of that software around in the 1980s. That was one of the few, one of the things it would be very easy for a teacher to code up and have children sitting in front of the computer and playing. There were other ways of using it too, of course. Come the 2000s, you have something which is a lot more social as a learning environment, but the sort of stimulus response reward still going on as teachers show pictures to children and ask children questions and then ask them to respond to that. You then have a more individualised approach to this with the sort of voting device, the class response system. So this is the Promethean one called the active vote, but there was another one which Smart make available, and you can do a very similar thing these days using mobile phone apps if you've allowed children to use mobile phones. So teacher displays a question on the board, child votes for it using the little device thing. Typically a graph gets displayed on the board showing what the correct answer is or what the popular answer amongst the class is. The child themselves knows whether they've got it right or not, but there's no sort of sense of them being shown up in front of their friends for having got the answer wrong. And of course a record is generated out on the database or the spreadsheet that the computer will produce at the end of the quiz session as to who got which questions right, who got which questions wrong. You can do all of this sort of thing very easily inside a virtual learning environment too. Moodle has a huge number of tools built in to allow that sort of stimulus response reward questioning, as well as lots of other more interesting, value judgment slipping in there, and lots of other approaches to computer-assisted learning, such as collaborative workspaces and discussion forums. So the quiz tool in Moodle is really very, very powerful indeed, and that sort of immediate feedback for children, for learners, as they're attempting questions online is something which I think does have particular benefits, certainly inside maths education, but other domains too. And nowadays, bringing it up to date, we of course have the handheld devices, and I don't know how many of you have played with the brain training type programs on the Nintendo DSs and similar, but you have stuff which is exactly the sort of thing which Skinner would recognise here as stimulus, response, reward, that sort of immediate feedback depending on how well the child does with something like this. Okay, so that's kind of where we've got to. The interesting thing around much of this, and you saw that in the Skinner video, is this notion of an individualised learning programme, of each child progressing at their own rate. So this became something which was very interesting when we were sort of back in the sort of 2006, 2008, that sort of period, where we became, or government became very interested in this notion of personalisation as a theme across the whole of the public sector, really. And the more extreme modes of personalisation are what we would term choice and voice personalisation, that those who are using public sector services should have a degree of choice in which services they access and should have some say in how those services are provided. In education terms, this happens alongside the move to assessment for learning, that we have that tight feedback cycle between how a child is doing and where they move on to next. And so that notion of individual target setting, of your assessment of a child's work, informs the next stage of their particular learning journey. And this is bureaucratized through the mechanism which we call assessment of pupils' progress. I think it should be, rather than performance, their APP, where you are using national curriculum level-based assignments to set targets for where the child moves on to next. In technology terms, you have this notion of adaptive learning design, where the computer provides the right learning object that comes next. So Skinner's machine and Press's machine would work through a list of questions, and for each of those you would respond in a particular way. We have the ability now to adapt things using the computer much more closely to how well the child is doing. So if the child is really struggling with a particular activity, we can set easier questions. If they appear to be flying through a particular activity, we can set harder questions at the next stage, so that there is a similar learning journey, but they can progress through that at their own rate. Ruth Kelly talks about this notion of the personal online space in her introduction to the E-Strategy back in 2005. She was then Secretary of State for Education. In the future, the online space is more than simply a storage place and e-portfolio. It becomes a digital space that's personalised. It remembers what the learner's interested in and suggests the relevant websites or alerts them to courses and learning opportunities that fit their need. Think, if you will, of SatNav for learning, as we talked about back in the induction lecture, or of the Amazon Recommend system. You seem to have enjoyed this sort of learning activity. Have you considered this sort of learning activity? Or other learners who struggled with this topic found this particular set of questions, learning resources, learning objects, helpful. Personalization was discussed in the school's white paper under the previous government. They defined it in terms of a tailored education for every child, for every young person. An opportunity for every pupil to be able to extend their learning, develop their interests and aptitudes, and how good schools were already making use of ICT in those terms. And this set the agenda that by 2008 all schools should have access to online or e-learning resources in and out of school, this notion of the learning platform available for every school. Although that wasn't actually what it said. We will encourage all schools to make available a personal online space to every pupil is one thing. An institutional learning platform is perhaps quite something else. This is, of course, under the previous government, and I think the agenda has moved on somewhat since then. And it's interesting that whilst we met that target, although possibly closer to 2009 than 2008, relatively few schools are actually making use of this personal online space in the sense of the institutional learning platform, although perhaps many more making use of a different sort of online space, such as the school's blog. It would be interesting to get some statistics on that. Adaptive learning design, I'll give you a moment here just to copy down the diagram into your notes. What we have there, though, is this notion of the computer being able to adapt or choose from a collection of learning objects, the ones which are displayed to each learner in turn. So there is this collection of the learning objects, and they are chosen from and provided to each learner as they access it. So there is this model of the student. The computer has an understanding of what the student has already been able to achieve and chooses or uses a statistical engine to provide the next set of objectives, the next set of learning opportunities in a sequence. You're starting to see this coming in with a range of different technologies. This is the RM Maths suite, which is again based on the notion of adaptive learning design. It has a good model of what the student has already achieved, and there's a clear sense of where the student ought to be getting to, but it will adapt its choice of the next activity depending on how well the child has done. This is very much marketed at schools. This, on the other hand, is marketed at parents for their children, so it's the notion of Carol Vorderman as your child's maths tutor. Let me show you the sort of thing that's going on in here. Here we go.
Well, now you know about counting up from 1 to 10. Let's have a look at those numbers again and see if we can find any missing numbers. Okay, we've got to find out what's missing from this line. 1, 2, that's correct. 3, 4, 5, 6, 7, 8, 9, 10. Very good. Let's try another one, see if you can guess. Yes, we've got a missing box here, so that's 1, 2, 3, 4, 5, 6. Very good.
I won't show you more of that. Let's just exit that.
My online arithmetic school has been...
shush. I want to try and get you back to the previous... There we go. So we get to play the game here. When we're ready to start, press the button. So what have we got? Put the numbers in order. Let's see what happens if I go wrong. Oh dear. Okay. Is happy with that, so I can attempt this various ways. Stimulus, response, and with a bit of luck, a reward. Oh. Thank you. There's my reward. Click here to move on. And we've got the same sort of thing in this middle section there. So, but again, this is based on this notion of adaptive learning design, that it will display the right, it will move the child through at a faster or slower pace depending on how the child's doing, and it will provide the right sort of activity depending on what the child has struggled with or what the child has succeeded at. What we're going to do in the session is have a go at coding up something perhaps not quite that sophisticated ourselves. We're going to code up a simple arithmetic game, or if you want to, a simple spelling game inside Scratch using some of the blocks which are displayed on screen here. So there are various mathematical things we can do. I'd draw your attention to the pick random number thing, which obviously would be jolly useful for this sort of thing. And there are ways of keeping track of the score, and there are ways, of course, of making the questions harder as we progress through. So that's where we're heading when we come back into the session. Now, Papert, of course, none of these lectures would be complete without some reference to Seymour Papert. So back in 1971, which is a long time ago, Papert was way ahead of this particular curve. So what he's arguing here is that rather than sitting the child in front of the computer and making them do lots of drill and practice programs, you know, this sort of computer-aided instruction side of things, far, far better to get them to write these programs themselves. It's said that the best way to learn something is to teach it. Perhaps writing a teaching program is better still, in its insistence on forcing one to consider all possible misunderstandings and mistakes. He'd seen children for whom doing arithmetic would have been utterly boring and alienating, become passionately involved in writing programs to teach arithmetic and in the pros and cons of criticism of one another's programs. Like, don't just tell him the right answer. If he's wrong, give him useful advice, discussing what kind of advice is useful. And this leads into deep understanding both of the concept being taught and, for Papert, importantly, the process of teaching and learning. And I hope you'll capture something of that magic when we have a go at writing our own teaching programs on Friday. I would like you very much to write in a question based on what you've just been watching into the comment space on Blogfolio, and next week's work I'll talk about when we are together in a session. But there's this electronic text which I'd like you to get out of the library. There's a couple of chapters that I'd like you to read, but we'll come back to that when we meet. Okay, I think that's time for me to stop the recorder. Do look back over any of this material if you'd like to, have a look at the readings in there, and post a question into the comment space.